Good day, students. Today we are going to look at hybridization in carbon bonding. Okay, as we covered last time, we had two sets of electronic configuration for carbon. The first one is electronic configuration for carbon, the ground state, and the second one is electronic configuration of carbon in the excited state. As I mentioned last time, you can actually see that in the ground state we only have two lone pairs, non-bond lone pairs of electrons, okay? And if we then promote one electron from the 2s orbital to the 2p, we're now going to have 1, 2, 3, 4 unpaired electrons. So that can actually enable carbon to form 4 bonds, okay? So if we were to label our these boxes, this stands for 1s, this is 2s, and this is 2p, okay? So the difference is we have two lone pairs in the first one in the ground state, electronic configuration, but in the second one we now have 1, 2, 3, 4 lone pairs of electrons, and therefore we can actually form 4 bonds. Right, suppose we now have carbon in EV, okay? Now let's look at what is happening at each carbon atom, okay? Let's look at what is happening at each carbon atom. All right, remember at each carbon atom we're going to have 2 hydrogens, okay, like that, okay? So we're looking at what is happening at each carbon atom. All right, so at each carbon atom, let us suppose one carbon will form a sigma bond. So the 2s, we're going to have the other carbon forming a sigma bond, right? So that would be our sigma bond. Remembering that our sigma bond refers to the head-on overlap of orbitals. So we have a sigma bond, and then that 2s orbital is done. All right, so if you look at this carbon now, what is happening here is also what is happening there. So we're going to have a hydrogen forming a bond there, okay? So we're going to have a hydrogen forming a bond here, and then we have another hydrogen, okay, forming a bond. So we have 1, 2 bonds, all right? But you notice what is happening at each carbon atom. We have, okay, 1 p electron, which is not going to be involved in bonding. So we have, remember the shape of our p orbital, we have an electron there which is not involved in bonding, okay? The p orbital is shaped like a dumbbell, okay? We have an orbital there above the plane and another orbital above the plane, okay? If I can just explain again, I said at each carbon atom we're going to form this bond. It's going to the orbital for this, the 2s orbital of this carbon and the 2s orbital of that carbon are going to overlap head-on to form a sigma bond, okay? So that is illustrated by that. And then we have a 2p orbital overlapping with the 1s orbital of the hydrogen. So it's happening in this box and in that box. So that's 1, 2. It's illustrated by 1, 2, okay? So at each carbon atom, this is what is happening. So we remain with 1 electron which is not involved in bonding. This is 1 electron which is here. So what is happening here is exactly what is happening there. So we have an electron which is not going to be involved in bonding, okay? Right, so at the end of the day, we have a sigma bond that has been formed, but we have electrons that in the p orbital and not involved in bonding, okay? So what will happen at the end of the day, the orbitals which are on either carbon, they are also going to overlap sideways, okay? So what we are going to have at the end of the day is going to be overlapping sideways, okay? So at the end of the day, we're going to have a diagram which will be like this. We have a sigma bond here, okay? So these orbitals will overlap, okay, above the plane and also below the plane, okay? And at the end of the day, we are going to have this sausage-like shape, okay? And the sausage-like shape is a sideways overlap. So we are talking here of sideways overlap above the plane of the molecule and below the plane of the molecule. And this sideways overlap, we'll call it the pi, okay? We're going to signify it as pi, All right, so sideways overlap of the molecule is known as pi. So we can label it as pi. Okay, sigma bond is head-on overlap of orbitals, and sideways overlap is called pi. Okay, so we are going to illustrate this molecule as our double bond. Okay, so in the double bond, we are going to have sigma bond and a pi bond. So every double bond that you talk about will be illustrated by a sigma bond and a pi bond. That's why a double bond will actually be stronger than a single bond. But let's analyze what we have done here. In this type of bonding, obviously we used s orbital, but if you look at what we used for the p, we did not use all the p. We only used 1, 2, okay? So the hybridization that happened here was 1s and only 2 p orbitals were used. These lone pairs of electrons were not used. They ended up overlapping for this carbon and for that carbon. So this type of hybridization is different from the previous one that we talked about. So all double bonds or all alkenes in hydrocarbons, okay, they tend to show what we call sp2 hybridization, okay? Unlike when we used 1s and all the p orbitals in alkenes. So alkenes tend to show us sp2 hybridization. It's important that you appreciate the difference or the differences that exist between sp3 and sp2 hybridization. In sp2 hybridization, one of the p electrons was not involved in bonding on either carbon atom, and then those electrons were actually allowed to overlap above and below the plane of the molecule, giving us what we can call a pi bond. So in every double bond that we have in alkenes, it's a combination of a sigma bond and a pi bond. In my next session, I'm going to look at alkynes. So far, I've explained alkanes. Okay, alkanes will give you sp3 hybridization. Alkenes will give you sp2 hybridization. So in my next session, I'm going to look at alkynes, which are triple bonds. We're going to analyze what type of hybridization we have there, and at the end of the day, we're also going to discuss the bond angles that we have in sp3 hybridization, the bond angle that we have in sp2 hybridization, and the bond angle that we have in sp hybridization. Remember, if you like this video or you find this video very useful, remember to subscribe, like this video, share with your friends, so that we'll be in a position to revise for our exams. This was a revision session, a lecture on hybridization in carbon bonding, syllabus code 9701 chemistry. Bye-bye for now.